13.4 is translations. Hey, focus, friend, focus. 13.4 is translations. Okay? Lots of vocabulary today. A transformation is a type of translation. A transformation is a change made to the location or the size of a figure. So when a figure changes locations or it shrinks or it gets larger, that's considered a transformation. An image. The image is the new figure formed by a transformation. Okay, so it's the new thing that you created. And the translation is a transformation in which each point of a figure moves the same distance in the same direction. Okay, so we have translations happening on these two graphs. This is how you read these graphs in your book. Whatever has these little tick marks, okay, is the new image. Okay, so the new image has tick marks beside it. The old image, the original image, is just A, B, C, or D, E, F, or whatever letters they use. The new image has those little hash marks next to it. Okay, so when we are describing this translation, that means we need to look at this figure and decide, how did this figure get down here? What happened?
Transformation.
It's not a reflection. It moved what? Did it move to the left or right? To the right. How much did it move to the right? Here's how you determine. Choose one point. I don't care which one. Let's look at C. How far did C move over? 1, 2, 3, 4. 4 units to the right. Okay? And then did it go up or down? How many units did C move down? No, it moved down 1, 2, 3. Okay, so it moves. So to describe this transformation, you say 4 to the right, 3 down. 4 right, 3 down. That's fine. Okay, it moves 4 units right, 3 units down. Now, here's another one. How did that transformation take place?
It moved to the right.
Oh, time out. I'm hearing it move to the right. I'm hearing it move to the left.
No, the blue one.
Yes, this is the new image. This is the old image. So it moved to the left and it moved down. Now, look at D. How far did D move over? 1, 2, 3, 4, 5, 6. So it moved to the left 6 units. 6 left. And how many did D move down? 1, 2, 3, 4. 4.
Can you move Jason from out of the front of the row? We can't see.
And it moved 4 down. Okay, it moved 6 left, 4 down. Now, that's just when they want you to describe what's happening in the picture. Okay? If they want you to put it in coordinate notation, okay, that means they want you to give us like an example of what happened. So a coordinate is an x, y factor, yes? Like x is my point, y is my point, that's a coordinate. Coordinate notation is x plus a and y plus b, meaning this. Look at this image here, okay? This is the original image, this is the new image. If I look at A moved to the right 1, 2, 3, 4 units, right? So when I go to put it in coordinate notation, I say x plus 4. If it moves left, what would it say? X minus whatever, okay? And then A also moved down 1 unit, right? From here to here. So it moved 4 that way and down 1 unit, so it's y minus 1. That's how I write coordinate notation.
So x plus y.
No. X plus whatever it moved to the left or right, and y plus or minus whatever it moved up or down.
Left and down is
So if you move up, it's plus.
If you move up, it's plus. If you move down, it's minus. If you move to the right, it's plus. If you move to the left, it's minus. Okay? That is coordinate notation. So when they ask for you to write it in coordinate notation, they want it written that way. Now, Here it says find the coordinates of the vertices of the image after the translation of x, y is x minus 6, y plus 2, and draw the image. So what do I need to do to each of these points before I can draw the image? Carter?
You need to like move the point of like I'm just gonna put C over to the left and make point and just like make it out.
Well, sort of. Let's do it an easier way. Let's do it mathematically. What does it tell me my coordinate notation is? X minus 6, y plus 2. So if I take this coordinate of 5, 2, that means I say 5 minus 6 and 2 plus 2. What's my new coordinate for C? Negative 1, 4. Okay, so that's going to be my new C. My new B would be 3 minus 6 and 0 plus 2, which gives me what?
Negative 3.
No,
Negative 9.
Negative.
Negative 9.
How about negative 3?
You said
3 minus 6.
I said negative 3 and you said
No, I didn't say no to you. I was saying no to Jason. I never heard yours. So negative 3 what?
3.
Positive 2. Negative 3, positive 2. Now A would be, I plug 3 in for X. I subtract 6 from it. I plug negative 4 in for Y. I add 2 to it. Negative 3, negative 2. So now I can regraph these. I go to negative 1, positive 4, because it's easier to do it this way than to try to shift everything manually. Does that make sense? And I label it like that. Then I go to negative 3, positive 2, and I label it this. Then I go to negative 3, negative 2, and I label it like this. And then I connect the dots. And I make my new triangle. Okay? I want you to show me this math. Some of you did not show me work on your quiz yesterday. I need you to show me the math. Okay? When you are doing your homework tonight, and if they ask you to draw the original image and then translate it, I want it done in 2 different colors. 2 different colors. So you can use a pen and a pencil, but I want it done in 2 different colors. Okay? And when you label your mapped image, you better have these tick marks with it or I'm counting it wrong. Okay? A tessellation. Tessellation is the last thing we need to talk about. It's a covering of a plane with a repeating pattern of more shapes. Okay, look up here on my walls. See all these pictures?
Sure.
These are all tessellations. Okay? So they're tessellations because the object repeats and there's no overlap of any of the object. Okay? There's no overlap, but the object repeats continuously. These are some elaborate ones, especially these 2. These are cats and mice and fish and dogs, and this one's flowers. Okay? So we have to be able to tell whether you can create a tessellation using only tessellations of the given polygon. Meaning, I can only use this shape and I can only use this shape for this one. Okay? Like this shape here is up here in this one. Do you see that one right there? That tessellation? Okay. What shape is in between that tessellation? Square. So do you think I can create a tessellation off this shape without using other shapes? Why not?
Because the way shape or the way.
Because they want to fit together. Yeah, because if I take the squares away, in order for there to be no gaps, I would have to overlap. You can't overlap for a tessellation to happen. So even though this is a regular polygon because it's marked all sides equal and all angles congruent, even though it's a regular polygon, that shape cannot make a tessellation by itself. It has to have other shapes with it. Can a diamond shape make a tessellation by itself?
Yes.
Okay. Why is this able to make a tessellation by itself?
Because they fit together.
Because they would fit together. If I redraw this, right, I would have like another one coming here, here, here. And then I could make something like this. If I was a good artist, it would actually work like that. And I have it keep going like this, yes? Do you see how there's no gaps in that tessellation? Okay, it's just a repeated shape over and over and over. So this one here with these arrows, it doesn't need any other shape besides that arrow that's going on. So that is a regular tessellation with one shape. Okay? You're going to have to be able to look in your book and describe that in words for me if things can happen as tessellations. Questions on any of this? Okay, you probably will need graph paper today. Yes.
Oh, you said like
I didn't know.
tessellation with shape
I'll
B,
have
which is
graphic.
a hexagon, but tessellation.
Yes, but that's because there are other shapes in between that hexagon.
It's too expensive.
Oh, you mean this one over here? 1, 2, 3, 4, 5, 6. Do you see how that is an irregular hexagon though?
Oh yeah.
It's not the same side lines. That's why. This one's a regular hexagon, so it's not possible. Good question, right?